In this problem, we're going to be talking about the graph, the domain, and the range of an exponential function. So let's recall that anything of the form f of x is equal to b to the x power have the points 0, 1 on them because we're putting a 0 into the exponent. Anything to the 0 power is 1. And 1 comma b, which means we're putting a 1 here, and anything to the 1 power is just itself. Okay. They also have horizontal asymptote of y is equal to 0, which is the x-axis, unless it's been shifted up or down. And we're going to use these transformations in this order. So this will be horizontal shift up and down. This will be stretching and shrinking. This is going to be reflection, and this is going to be the vertical left and right. Okay, so let's first look at this one here. We got f of x equals 3 to the x plus 3. The parent function, they gave us 0, 1. Okay, and the parent function is 3 to the x, right? Without the plus 3. Okay, so it's 0, 1. So if we put a 1 in there, the base is 3, so it would be 0, 3. Okay, now what happened to the transformation? So what is this x plus 3 going to do? Well, since it's on the inside with the x instead of like all this and then a plus 3, it's inside with the x. Okay, so this is going to make it shift left by 3. Okay, remember when it's an inside shift, it goes left and right. When the number is outside, then it's up and down. Okay, so this one would shift left by 3. Is there anything else going on besides that? So we'll do the first thing first. We'll shift left 3. Okay, which means if we're shifting left 3, we're switching the x value, not the right. Left and right is x, right? This is the x-axis. So if we're shifting left by 3, instead of 0, 1, you shift that over and it would be -3, 1. So there's a point here. If we shift left by 3, which would give us -3, comma 1. Okay, and again, we'll do a shift left 3. Okay, so this would be 1, 3 originally, but we're going to move it over to the left by 3. So 1, 3 is here. 1, 2, 3 is here. Okay, so we also have our asymptote here, which is going to be like this, so it doesn't get shifted at all because it's a left and right line, so it's not going to get shifted left or right. Okay, so there we go, and we could draw the graph of this thing. It should look something like an exponential. Okay, so this is no shift on that. Okay, so I forgot to write this other point up here. Since this was 1, 3 and it shifted left by 3, it would be -2, 3. Okay, now we can take a look at our domain and range. Our domain and range, see the domain goes left and right forever. All right, so even though it looks like it's going straight up, it's still going to be moving right. The higher it gets, it's moving more and more and more right. And this obviously it's pointing left, so it'll be -infinity to +infinity. Okay, the range though, it will start at 0, that's the lowest point, and go up. So the range is 0 to infinity. And I'll put a parentheses on all of those because infinity always gets parentheses. And 0 starts because there's an asymptote at 3. So it's going to be above 3. You're never going to go below that axis. Okay? And our horizontal asymptote is still y equals 0 for our HA, horizontal asymptote. All right, let's look at the next one. So we've got 2 to the x plus 2. Okay, so we look at the parent function, which is just 2 to the x. 2 to the x, but it gets shifted up. That's the y value, right? It's going up and down. That's the y-axis. So plus 2 is going to go up and down. So instead of 0, 1, like the parent function, the y value gets shifted up 2. So this becomes 0 stays the same, but the 1 becomes a 3. The parent function is 2 to the x, so if we plugged in a 1 into the parent function, just 2 to the x, it would be 2, but we're going up 2, so up 2 would be 1 comma 4. Okay, the horizontal asymptote was y equals 0, but again, it's going up 2, so our horizontal asymptote is y is equal to 2. Okay, so we can have a little line here for our new horizontal asymptote that got shifted up. Okay, and then we can plot the points 0, 3, and then 1, 4. Okay, so it should look something like this. Okay, so now we can talk about the domain and range. The domain, just like the last one, it goes left forever and it goes right forever. Okay, so the domain is from negative infinity to infinity. The range, however, starts from 2, our shifted up horizontal asymptote. So it starts from 2, not including, to infinity. Okay, and we have our new asymptote there. Okay, on this one we have 1/3 to the x minus 2. Okay, so this thing is going to make everything go right by 2 because the minus 2 is up there with the x. It's not out here, like adding on or subtracting out here. It's up there with the x. So it's going to go with the opposite sign of whatever that number is. So since it says -2, we'll go right by 2. Okay, so your 0, 1 is your parent function. We're going to go right by 2. Okay, so that is the x, so it will be 2, 1. Okay, left and right of the x. So I go right, that means pause, add 2 to it, so 2, 1. The parent function of this would be 1, 1/3, because the parent function doesn't have the -2 on it, right? It just has that 1/3 to the x power. And if I put a 1 in there, it's just 1/3. But I go right by 2, so that means the x value becomes 3, 1/3. Okay, we've got y is equal to 0, but we don't have an up and down shift, right? So there's no transformation of the horizontal asymptote because it would have to either go up or down, but all it did was go right. So it remains, the asymptote remains at y is equal to 0 right here. Okay, so none and y equals 0 still. All right, domain. Well, actually, let's plot those points. So 2, 1. 2, 1 is here, and then 3, 1/3 is here. Okay, so let's see what we have. Let's plug in one more point just to make sure we know. I'm going to plug in a 1 into this thing to get one more point. So if I plug in x equals 1, that would give me 1/3 to the 1 minus 2. So that's 1/3 to the -1, which would be, if you flip it, it becomes 3/1, or just 3. So 1, 3 is on the list as well on our new one. So 1, 3, and that gives us a better idea of what's going on with this graph. It looks like it's doing this, and then leveling out there forever. Okay, so domain is the same. It doesn't change. It's always negative infinity to positive infinity. The range is going to start from 0 and go up. So from 0 to infinity. All right, one last one. So the most complicated one. So the base parent function of this is just 1/4 to the x. Okay, so that's 0, 1. But the transformations are as such. First, we look to see if there are any horizontal shifts, and that would mean that this number would have a plus or a minus on it. It doesn't. Okay. The next thing is the stretching or shrinking. So does it have a number out in front that would cause it to stretch or shrink? All it's got is the negative sign out front. So the negative sign will reflect it, but it won't stretch or shrink it. Okay. Now we will look for the reflection, which means you have a negative sign out front, and we do. So it gets reflected first, reflected across the x-axis, and then we do the -2. Okay, so reflect over x-axis, and then subtract 2, and then go down 2. Okay, so if we reflect over the x-axis, that means that instead of the point 0, 1, which is here, it's going to reflect to be down here. Okay, so it reflects, instead of the point 0, 1, the parent function, 0, 1, it's going to reflect across the x-axis and come down here. And then it goes down to 1, 2. Okay, so instead of 0, 1, which is the parent function, it first gets reflected, and then you do the -2, and it goes down here. So there's a point right here. Okay, let's go back to this point. So 1, something, we plug in a 1 into the parent function. The parent function is 1/4 to the x. Okay, so it would be 1, 1/4. But we get the same thing. We reflect over the x-axis and then down 2. So I go to 1 1/4, which is about right here. 1 on the x and 1/4 on the y, which is about right here. We flip down to the bottom, and then we subtract 2. So 1, 2. It should be right there. Okay, so let me walk through that again. We go from 1 1/4, which is 1 1/4, flips over, becomes negative a fourth, and then goes down 2. There's our point, like negative 2 and a fourth. Okay. And we do have on this last one, oh, let me write these points. So the first point up here after I reflected was 0, negative 3. The second point after reflected and subtracted 2 was 1, comma, negative 2 and a quarter. Okay, and then the last one, since the reflection doesn't change the line of symmetry being here, because you can't reflect if you're already on the axis that you're reflecting around. But we can go down 2 from this, so our new one would be going down 2, which would make it y is equal to negative 2. So there's our asymptote right there. Okay, and if you can see that that's the asymptote, then you know that the graph is going to get right here, right up against that thing right there, and go up over here. Okay, so now that we've got that, let's look at the domain and range. The domain goes left and right forever, so that's still negative infinity to positive infinity. And then the range goes down forever, but it stops at negative 2. Okay, so negative infinity to negative 2, non-inclusive. Okay, here's our new horizontal asymptote, and here are the other points.